Hello and welcome back to these advanced sessions for CREO BMX. And today I want us to discuss on how you can you can determine volume of maybe of your bottle or whatever you have and set it to a certain value. You can see here on this tree, I have some parameters that are calculating the volume after shell and pre-shell, and I said this volume has to be 10. And this volume, when this plane is on a certain level, yeah, like here, this volume is 10 liters. If you try now to change it height, you see the volume is changing. Therefore, you're going to see how you can calculate this volume and how you can set this volume to be 10. Because right now, if I was to go back, if I was to try to look for a value that will give me 10 volume, would be so difficult. Therefore, let's see how you can go about it. I have a simple sketch here, a simple geometry. Let me first for deactivate cross section. Let me hide that. Yeah, this is the yes. You can make your simple design there. Yeah, I made I made it simple like that. A simple profile. I just extruded, then made another one there. Some fillets. Then what I did. Let me open it. Let me open this. Let me show this plane. I know I'm going to shell this by 5 mm, therefore I know the bottom of the liquid has to be 5 mm away from the surface. Therefore, the first plane is to reference the bottom of the liquid, that is 5 millimeters away. Because I'm going to shell this battery to be 5 millimeters away, we will have a thickness of 5. Another plane, this plane determines the height of the liquid. Therefore, this height. Therefore, I can say let's have a height of maybe 100. This one is the height. You can see height of liquid inside or fluid, whatever is there. This is the bottom. I don't need it. This is the plane that controls the height of the liquid. Therefore, at this point, we can calculate the volume. When you get the volume below the plane, then you get the volume of the material. Then you subtract those two volumes, you're going to get the volume inside. Therefore, let's first find the volume underneath. When I say volume underneath is, let me go to view, let me cross section here. This is the volume I'm talking about. This volume, because this volume is below the plane. Therefore, we go to analysis. In fact, let me suppress all this. That yeah. Therefore, go to analysis, measure. We are measuring volume. You want to measure volume. The volume wants to measure, you have to use a plane. You have to difference this plane here. This arrow means we are measuring the volume on bottom side. But for me, I want to measure the volume on. If you want to measure the volume upside, just select the arrow here, or can select here. So then next is I want to measure the volume. If you go to feature, you can change this to volume like that. Okay, can say maybe vol. Let me give another. So maybe for to avoid confusion, volume, volume. Maybe just put a name or volume B for battery like that, and you can save. Yeah, close. You can see now we have this measure volume here, and we said the feature parameter is having a volume B, volume for both tree. But you see, we don't have that volume here on the tree. Therefore, I'll go to the tree column, onto the feature params, you write that volume B and add it, apply. You can see now we have another one here called volume B. Yeah, if you want to go back to make it cap to letters, you can still do the same. And we are getting same volume here. You can see. And this is the volume we are getting before shell. Before, let's call it before shell. Like that. Let's now shell our body. We are going to shell here. We said we're going to shell by 5 mm. Like that. Yeah. Let me cross section one side so that you can visualize. Let me just pull a little bit like that. Let me use, yeah, so yeah, like that. Yeah, remember now we are measuring volume. We're going to measure the volume of the plastic casing or whatever the material used to make your bottle. Therefore, that is the volume after shell. Therefore, we can go back to analysis, measure the volume, use this plane, bottom side fine. Here I can call it vol underscore B and say, yeah, and save, make feature, like, yeah, that. You can see now we got another volume here. And this one is a after shell. After shell. This is a volume after shell, but this volume and this one is a volume of after shell. We can now subtract, can take before shell minus after shell to get the volume of the liquid or the fluid. Therefore, for us to perform that relation, you go to analysis, you select relation here, and call it volume calc. Volume in calculated, whatever the name we are going to use, go next, add the same parameter. If you want the parameter to be displayed, the value, use the same parameter, otherwise you can use yours like that. But for me, I want the quantity. Maybe you want your volume to be in liters. Well, right now we are using millimeters cubed and convert one to this. And you can insert into relation this volume B and say this volume equals a feature which is before shell, insert, minus something else I want to mention to you. As you can see, volume B, it looks for a name with a volume B. Remember we said this volume B is this one here, must be equals to FID, feature ID 596. You can see, looking for feature ID 596 here. I can also type it. I can also say minus volume underscore B. Then I can say feature ID underscore 763. I can still type it. Yeah. Therefore, this 763 is after shell. Before shell, after shell. Let's do comment here. This is the before shell minus after shell. That. And say okay. Okay. You see we are getting 8 liters, 80.395309. You can see also these ones, although they are suppressed, they are still giving us the correct value. Okay, therefore I can see this one is um, volume in the bottle, the bottle spelling there. Okay, let me rename. Yeah. Therefore, now we have this volume that is 18.395 liters. But I want this volume. What is happening here? It went where? Okay, I want this volume to be exactly 12 liters. Okay, I'll go now to analysis. I'll go to sensitivity analysis, and here, um, therefore, for you to be able to define new parameters here, the best way is for me to, instead of suppressing them, let me delete, because I don't need them now. Now go to sensitivity so that I can see this volume in a bottle. If I was to vary the height of this plane, this 100, I want to change from 70 to 200 or maybe to 400. I want to use allowed to 40 minus 70, 170, 171. Let's see. It calculates, it varies the height of the plane position, performs a relation to get the volume in the bottle, again gets new. As you can see, we are having a linear change because I've used I took to 40 minus 70, I got 170. Then I said plus one extra because of how it will start. As you can see, it will reach a point whereby even if this plane height increases, the volume doesn't change. Okay, and I know, of course, you can guess why this is happening. It's because now this volume, this plane will be above this surface. This plane goes above the surface. But if you go above the surface, the volume will never change. And you can see, I want to say, I want my volume to be exactly 12. Therefore, I need a value here. If you select there, if you put your cursor here, it can give you approximate 144. That is the value. The volume is 12.0. I want 12 exactly. Therefore, I know I need to be between 140 to 150. Or I can say 142 to 146, whatever. Let's say 142, 140 to 150. 140 to 150. Therefore, I go to feasibility, 140 to 150. Let's do that. This one here. We said 140 to 150. And the parameter we want to change is the volume in the bottle here. Volume in the bottle, set it to 12. Like that. Okay. Then I want to animate model. You see this plane moving, and I want my answer to be more accurate. That it compute. That was very fast. The one iteration, we could get 12 with one iteration, and you can see we are getting this value. This is the value 143. It is between 143 and 144 there. Let's see if this is true. If I cross there, I can say accept the dimension, and we can see we are getting exactly 12 liters. Okay, if you want to validate this, you can go volume. You can measure volume. If you want to measure, the measure from this plane, and you see this is in millimeter cubic. Yeah, you see we are getting 157 here because this one is calculating this volume. 157, 157. You can see we are getting exact, and the volume between those two becomes 12 liters. Okay. You can also, let me go back here to show something else. Once you compute like that, you cannot select the stick and say optimize one. You see all this happens. When I say optimize one, if you try to change anything, any dimension, let's say, let's go to the front view. You can see where the plane is right now. If I was to change a dimension here, you will see this plane going down. Let me change this from 150 to 180, like that. The plane will shift. But now there's an error. Why? Because the reason why I got this is because we said it is between 140 to 150. Therefore, I have to go back here. Therefore, I have to go back here, edit, oh no, that there. I have to go back, edit this one here. Next, I want to say from 50 to 200, like that. Yeah. Now the error disappeared because now the plane, you can see now the plane moves closer to the down. Let's go here again. Let's increase this one. You see the plane moving up. Okay. It moves down because now the volume is bigger. You can see this plane. Let's now reduce them like that. Plane moves up because we want to maintain. You can see the plane. We want to maintain volume like that. You can see the volume is still 12. This doesn't work. Here we are. Let's go to 150. That doesn't work because now the volume is too small. Go back to 200. Okay, let's change this to 120. You see the plane? Yeah. So this is very powerful. It gives you the new, if you can change your dimensions without changing the volume. But you see the volume now has changed 11.999 because remember there's a place we said convergence and we said if I go back here, let me show why this has happened. If you go to optimization here, there's this option here called convergence. We say this volume must be within this percentage. Therefore, this value here is within this. Okay, I hope you have learned something, and let's meet in our next videos whereby I'll go deep a little bit to now discuss multi-objective design study, and also I will discuss optimization. You can have optimization where you have a goal to minimize or maximize something, and we're going to deeper on how to use optimization and multi-objective study. Then later we'll do some statistical design study whereby you have a variety of maybe variables and you want to get the best combination. We do some statistical design study whereby we're going to see the standard deviation. I will go deeper to this. It's a very, very powerful one. Thank you.